Inside Building Products, a Siemens podcast that keeps you learning.
Have you ever dealt with like a light switch that's just got two modes? You know, blindingly bright or completely off, nothing in between.
Yeah, or maybe like an old air conditioner that just blasts freezing air until the room's an icebox, then clicks off and blasts again.
Exactly. It's just
inefficient,
right? Kind of wasteful and definitely doesn't feel very smart.
Mm.
Well, that whole all or nothing problem, that's really what we're digging into today.
Right.
We're exploring this really clever bit of tech called variable speed drives, VSDs for short.
Sounds technical, maybe.
It does sound a bit technical, yeah. But honestly, don't worry about the name. We're going to break down why this tech is like a quiet revolution for efficiency.
And not just for engineers, right? For anyone who,
Yes.
pays an energy bill or just wants a comfortable building.
Precisely. So our mission today, understand what these VSDs actually are, why they matter so much for saving energy, and look at a specific example, the Siemens G120P. We want to see how it brings real intelligence, real savings to everyday systems.
And we've been looking at some good material, particularly from the Siemens Buildings Product Academy, to get the details.
Okay, so let's unpack that core problem first. You might not even think about it, but loads of motors in our buildings.
Yeah, running fans, pumps.
Exactly. Big stuff. They often work on a really simple principle, almost primitive, you could say.
The all or nothing thing again.
Yeah. Without a VSD, that motor's either going full throttle, max speed, or it's just off.
Imagine driving your car, but you can only floor the accelerator or take your foot off completely, no cruising.
Right. Just flat out or coasting to a stop. Not very practical.
And what's really fascinating and maybe surprising is that most of the time, these systems simply don't need to run at full power.
Oh, really?
Yeah, think about how a building actually operates. The demand changes constantly, right? Temperature, how many people are inside.
Sure, yeah.
So our sources are pretty clear. Typical fans, typical pumps, they often operate in what's called partial load, usually needing somewhere between, say, 40% and 80% of their max power.
Okay, so running them at 100% when you only need, what, maybe half that?
Exactly. It's a massive waste of energy. It's like keeping all the lights in an office tower blazing bright at 3 a.m. Pointless.
And I guess that puts extra wear on the equipment, too.
Absolutely. Plus, it drives up your energy costs significantly.
Okay, so that's the problem. Big waste, systems running way harder than necessary. So what's the smart fix?
Well, this is where the variable speed drive, the VSD, comes in.
The hero of the hour.
Ha! Maybe. Think of it like a really, really precise throttle control for the motor. Or maybe a dimmer switch for electricity.
Okay, I like the dimmer switch analogy. Instead of just on-off, you get the whole range.
Exactly.
Yeah.
It lets the motor run at precisely the speed needed for the job at that exact moment. No more, no less.
How does it actually do that, though? At a high level?
Well, basically, the VSD takes the standard electricity coming in, the alternating current, AC.
Right.
It converts it to direct current, DC, and then converts it back to AC. But here's the clever part. It does it at a variable frequency.
Oh, okay. And changing the frequency changes the motor speed.
Precisely. So instead of being locked to the grid's frequency, the VSD listens to the system. Maybe sensors are telling it the temperature or the pressure.
So it knows the actual demand.
Yes. And then it fine-tunes the motor speed perfectly to match that demand.
So it's not just saving power, it's actually making the system smarter, more responsive.
Totally. It optimizes everything. Less stress on parts, longer life, smoother operation. And for you, the listener, that means, well, less wasted energy and lower bills. Simple as that, really.
Okay, this is where it gets really interesting. Let's look at a specific example we found in the sources. The Siemens G120P.
Right. This one's specifically designed for HVAC systems.
Heating, ventilation, air conditioning. The big energy users in most buildings, right?
Definitely among the biggest, yeah. Commercial buildings, private homes, schools, HVAC is crucial but costly.
And the G120P promises some pretty dramatic savings here.
Oh, yeah. The numbers are quite something. Our sources say the G120P can achieve energy savings of up to 60%.
60%, wow. Compared to the old on-off methods.
Compared to conventional control methods, yes. That's a huge chunk of energy cost just gone.
So when Siemens says G120P stands for efficiency, they really mean it.
It seems so. It's not just a minor tweak. It represents a fundamentally more economical way to run these essential systems.
How does it manage such big savings? Is it just the speed control, or is there more to it?
It's largely the intelligent speed control, but Siemens calls it intelligent control strategies. Fancy term, but it basically means it uses smart algorithms.
Okay.
These are specifically programmed to get the best performance out of fans and pumps. It uses real-time data, makes tiny adjustments constantly.
To ensure the motor is only doing the work that's actually needed right now.
Exactly. It's perfect for controlling airflows, water circulation, that kind of thing in typical HVAC setups, keeping things comfortable but efficiently.
And you mentioned wear and tear earlier. Does this help with that too, beyond just the energy bill?
Absolutely. That's a really important point that the sources highlight. The G120P also significantly cuts down costs related to wear, the overall life cycle, and maintenance.
How so?
Well, think about it. If the motor isn't constantly slamming on at full speed or cycling on and off harshly,
Less stress.
much less stress on bearings, windings, couplings, everything. So components last longer. You get fewer breakdowns, less need for maintenance visits, fewer expensive repairs or replacements down the line.
So it saves money on energy now and saves money on repairs and replacements later.
That's the idea. It's a double win for building owners or facility managers. Extends the life of your quite expensive equipment.
Okay, those operational savings sound great.
Yeah.
But what about actually installing and managing these things? Are they complex beasts?
That's a fair question. And actually, this is where another key feature comes in. The G120P's modular design.
Modular, meaning it comes in pieces.
Sort of, yeah. Basically, it consists of three main parts you can think of. There's the control unit, that's the brain. Then the power unit, that's the muscle, handling the electricity.
Got it.
And finally, an operator panel, the screen and buttons for setup and control. Or, if you don't need that on every single unit, just a blanking cover.
Ah, okay. So why is being modular a big deal?
Several reasons, all quite practical. First, cost efficiency. You pay only for what you really need.
Like the operator panel example. If I have 10 drives, maybe I only need one panel to set them all up.
Exactly. You don't need to buy 10 panels. That saves money up front. It also means reduced spare parts holding.
Right. Instead of stocking whole drives, maybe just keep a spare control unit or power unit.
Precisely. Less inventory, less capital tied up. And for maintenance, this is huge. If something fails, you usually only need to replace the defective part.
Not the whole VSD unit.
Correct. And here's a really neat trick. If you swap out the power module, the muscle part, our sources say no reparameterization is required.
Meaning you don't have to reprogram everything, all the settings.
Exactly. The settings, the parameters, they're stored in the control unit, the brain. So you swap the power module, plug it back in, and it should just work.
Wow, that must save a lot of time and hassle for technicians. Reduces downtime.
Big time. Less chance of errors during reprogramming, too. Gets the system back online much faster.
So pulling that all together, this modular approach means what for the user? More flexibility, lower costs overall.
Yeah, definitely more service flexibility, reduce costs across the board, purchase, inventory, maintenance, and just less resource waste, really.
Makes sense. Easier installation, simpler setup, smoother operation. It sounds like genuinely thoughtful engineering.
It considers the whole life cycle, not just the initial function.
Okay, let's do a quick recap then. What are the absolute key takeaways from this deep dive?
Well, I think the core message is pretty clear. The G120P is all about efficiency. You've got those potential energy savings up to 60%.
Which is huge.
Huge. And that comes from its intelligent features, specifically designed for HVAC fan and pump application.
And then there's the modularity.
Right, that modular design giving you flexibility, cutting costs on installations, spares, maintenance, making the whole thing easier to manage.
Plus the fact that those energy savings mean it often pays for itself pretty quickly.
Yeah, the return on investment can be surprisingly fast, turning that initial cost into a clear financial benefit.
And we shouldn't forget its versatility. It can be installed in different places, right?
Correct. Our source mentioned two protection types, IP20.
That's for inside cabinets, clean environments.
Yes, protected from fingers and larger objects, and then IP54.
Which is more robust. Dust and water splashes.
Exactly. Good for wall mounting in maybe slightly tougher environments like a plant room, so it's adaptable.
So it seems like a smart solution that can fit into a lot of different scenarios.
Pretty much. Tailored intelligence meets practical design.
Okay, well that wraps up another deep dive. We went from that everyday annoyance of all or nothing systems.
The blinding light switch?
Yeah. Understanding how this sometimes invisible tech like variable speed drives, and specifically the Siemens G120P, brings really significant benefits.
Making energy use smarter, not just harder.
Exactly. Saving money, saving resources, even making equipment last longer. Tangible stuff. So here's a final thought for you, the listener. Next time you're in a building and feel that perfectly comfortable temperature, or maybe notice the quiet hum of a pump.
Instead of a loud roar.
Right. Consider the invisible intelligence, like a VSD working behind the scenes, stopping waste. It makes you wonder, doesn't it?
Yeah.
How many other hidden inefficiencies are out there in our world? Just waiting for some clever tech, some smart thinking to unlock them. What other all-or-nothing systems could be improved in your own environment? Something to think about.
Definitely something to mull over.
We'll catch you next time on The Deep Dive.